Alright, this is the Unit 2 test review. Unit 2 test review, as you can see on the slides on the screen. This is pretty much what's going to be covered on the test. So pause when you need to pause. I'll be going through the slides pretty quickly, but obviously you can pause and practice to slow that down. So this is Unit 2 test review. Oh, there we go. Alright. Here's the rest of the stuff. You can see electron configuration, nuclear chemistry. So once again, this is all the stuff you need to know for the test. Alright, let's start with this right here, with the nuclear chemistry stuff. So first part here, let's sum up where the location of the stuff is. Protons are in the nucleus of the atom. Okay, so are neutrons. They're in the nucleus. And electrons outside the nucleus, or you can say in orbitals. That works as well. So electrons are hanging in orbitals. They're charged. Protons are a positive 1. Electrons are a negative 1. And neutrons are neutral. Relative mass. A proton is 1 AMU. A neutron is 1 AMU. And the electron is really, really small. Okay? It is really, really tiny. So small they really don't talk about it. If you want an exact number, it's 1 over 1,840 AMU. But just know it's really small. Alright, moving right along to this next part. As you can see here, we have isotopes. We're going to go through it, their mass number and their atomic number. We're going to pause for a second. Alright, here we go. Alright, so we see here cadmium 112. The mass number here is going to be 112. Alright, the atomic number, we go on the periodic table. Remember, it's one of two things that's found on the periodic table. One of them is the atomic number. On the periodic table is given to you. It's the whole number that's right above the symbol. The whole number right above the symbol. Okay? And if we flip over to the next slide, we'll see them on these slides. These numbers right here are the whole numbers right above the symbol. So here is cadmium, and we see this whole number is 48. And so our atomic number is 48. Sorry guys, that's a 4. Alright, isotopic notation. This is where we write the symbol of the elements. And if you go there, let's go back to cadmium. Our symbol here is CD. Alright, our symbol here is CD. So we're going to write capital C, lowercase d. And we have two numbers here. We put the mass number here. Remember, this is the mass number. And the atomic number goes down here to the bottom left. And this is exactly how you write it. Alright, number of protons is the same thing as atomic number, so 48. Number of electrons, since we're talking about atoms, these are neutral. It's the same number of protons as electrons. And number of neutrons, we go back to this mass number. Mass number is protons plus neutrons. And so if we have 48 protons, we take the mass number minus 48. Okay, so our mass number here is 112. We subtract our number of protons, and the number of neutrons is 64. So here is our number of neutrons. Fantastic. Going to this next one. If you want to pause here, you can try these two, fill them out, and then come back and push play and see what you got. Alright, so here we go. Well, here's our isotopic notation. So we know N is nitrogen dash, and again, this number is going to be the mass number, which corresponds to this here. So nitrogen 16. Okay, the mass number is 16. Atomic number is this one down here, 7. Number of protons is 7. Electrons is 7. And if we have a mass number of 16 minus our number of protons, we'll get our number of neutrons, which in this case is 9. Alright, for this next one, if we have 35 protons, we know the atomic number is 35. So With that being said, if we go over here, we can find that atomic number 35 corresponds with bromine. Okay? So we know this is going to be bromine. Now we don't have this mass number yet, so I don't have a number to put there, but we can figure it out. I have 45 neutrons, and I have 35 protons. So, to figure out mass number, it's protons plus neutrons. So here are my protons, here are my neutrons. Add them up, and get an announcement as we're trying to do this. So add these up, and we get a total of 80. So our mass number is 80. So this is bromine 80. So our isotopic symbol or notation is 80 over 35. Once again, mass number, atomic number. And number of electrons has the equal number of protons, so 35. And that's how you do mass number, atomic number, names, and symbols. Alright, average atomic mass. Okay, if you remember, average atomic mass is the other number that's on the periodic table. These numbers down here that have a bunch of decimals, these are the average atomic mass. So this question here asks, which isotope of lithium is most abundant? Lithium 5, lithium 6, or lithium 7? Explain why. So let's find lithium. Lithium's average atomic mass is 6.941. So I'm going to write this down the size here. So average atomic mass is 6.941 AMU. So that's the average atomic mass here. Alright, if you remember our rule is to round to the closest whole number. So this is going to round to 7. And so, the most abundant isotope is lithium 7. Explain. Alright. We're going to explain that lithium 7 is closest in mass to the average atomic mass. Okay, so we round this to the closest whole number, which is 7, and this mass number at the end, okay, is going to be closest to the average atomic mass. So we rounded it to 7, lithium 7 is the most abundant. If we're looking at calculating average atomic mass here, if you remember, our formula is average atomic mass is equal to your mass times abundance, that says abundance, divided by 100 plus your mass times abundance divided by 100. And you keep doing that for all your isotopes. So we have 3 isotopes here. So we're going to do that for all of them. So average atomic mass is equal to our mass, 35.97 AMU, times 0.0, I can read, 0.337%. We're going to divide that by 100, plus 37.96 AMUs times 0.063% over 100 plus 39.96 AMU times 99.6% divided by 100. And we'll plug this into our calculator. So 35.97 times 0.337 divided by 100, and on this one here I get 0.121 plus 37.96 times 0.063 divided by 100, and I get 0.024 plus 39.96 times 99.6 divided by 100, and I get 39.6 0.8. These are all in AMUs. So now I'm going to add these up. 0.121 plus 0.024 plus 39.8. And going to one decimal place, I get 39.9 AMU. Okay. And we can even figure out what element isotope or element X is. If we go to our periodic table, our average atomic mass is 39.9. So we go under 39.9, we can see it matches right here. And the element is argon. So I know in this question it didn't ask it, but just for future reference, you can match it up. All right. Electron configuration. All right. Electron configuration is the one with the 1s2 and the 2s2 and the 2p6 and blah, 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 blah. That's electron configuration. So let's see. Find the electron configuration for magnesium. You can try it at home, and we'll do it real quickly. So if we skip back, magnesium's right here on the periodic table. This is row 1, and remember these are S's. So if I go through row 1 and they're S's, oops, sorry about that. I write down 1 S, and I went through 2 of them, so 2 of them. And then right here, row 2, so this is row 2, and I go through 2 S there. So I write down 2 S2. And as I go through boron, carbon, all the way to neon, still the second row, and this is of the P's. So there are 1, 2, 3, 4, 5, 6 of them. So I've gone through 2p6. Now I'm in the third row, 3, and boom, there's magnesium. So 1, 2 over, and these are the S's. So I'm in the third row, the S's, and I went 2 over 3s2. All right, let's do another one. Let's try nickel. All right, nickel is right here. So this is where we're going to start at the beginning. We go through first row the S's, so that's 1s, and we went 2 over, so 1s2. We go through lithium and beryllium. That's 2s2. All right. We go through boron all the way through neon. Still in the second row, but we're in the P's now, so 2p6. We go through sodium and magnesium. 3s2. We go through aluminum all the way to argon. 4p6. Ooh, what am I doing? 3, that's a 3. 3p6. Now we get potassium and calcium. Now we're in the 4s. So we're at 4s. We went through 2 of them. And now here, scandium all the way to boom, nickel. So 1, 2, 3, 4, 5, 6, 7, 8 over. Now, we're in the 4th row, but remember these are the D's. So when you get to the D's, you take the row you're in, remember, and subtract 1. So if we do that, instead of saying 4, we write 3, and then D. And again, it was 1, 2, 3, 4, 5, 6, 7, 8 over. So we write down 3D8. That's electron configuration.